So section 3.4, we're going to be talking about polynomials, and we were talking about graphing techniques at the end of chapter 2, where we know how to move a graph left or right, and we know how to move it up or down. We know how to reflect it across the x or the y-axis, how to make them skinnier, wider, stretch them, shrink them, whatever words we want to use. But with polynomials, remember, a polynomial is a term or a sum of terms that have exponents on all the terms that are whole numbers. So no x's on the bottom of a fraction, no x's under any roots or radicals. And just from looking at the coefficients, looking at the degree of a polynomial, I'm just going to call this y. There are several things that we can tell. So we're going to talk about end behavior, and then we're going to also talk about how we can sketch a graph if we know about the zeros of a graph. Remember that in our basic shapes, our basic functions that we talked about, y equals x is a line that looks like that, and y equals x squared is a parabola, and y equals x cubed has that general shape, only it goes through the origin right there. When we talk about end behavior is what is happening as we are moving to the left or to the right in our graph. And when we talk about end behavior, we're talking about kind of the y values. So notice on y equals x, as we move to the left, our tail goes down. And as we move to the right, our tail goes up. But when we look at y equals x squared, both of our tails, both the left end and the right end, both go up. With x cubed, we're back to opposite directions, down to the left, up to the right. Now from the things that we learned from the end of chapter 2, if I want to look at the graph y equals negative x, or y equals negative x squared, or y equals negative x cubed, then that just indicates a reflection across the x-axis. So anything above hops down below, anything that was already below comes up above, and we have three graphs like that. Okay. Notice still with our y equals negative x that our tails move in opposite directions. Okay. Y equals negative x cubed, our tails move in opposite directions. And y equals negative x squared, instead of both pointing up, they're now both pointing down. That little spinning circle concerns me. Okay. When we're looking, pause the video. Okay. When we're looking at a function and trying to determine the end behavior of that function, meaning what happens as to the tail as we move to the left, what happens to the tail as we move to the right. There are two pieces of that function that we're worried about. We're worried about the degree. The degree is the biggest power of x. And we're worried about the leading coefficient. The leading coefficient is if we have our polynomial written in order of descending powers. So from biggest power of x to smallest power of x, the leading coefficient is the number that's out in front. Okay, the coefficient that's out in front of our variable x. With the degree, the biggest exponent, what we are worried about there is whether that exponent is an even number or an odd number. Okay. If our exponent is an even number, the only even example we had here was our x squareds in the middle. Okay, notice what happened to both ends. In the top situation, both ends went up, and in the bottom situation, both ends went down. When our exponent was odd, x to the first, x to the third, notice that our tails went in opposite directions. The degree, anytime we have an even degree polynomial, our tails are going to go in the same direction. Anytime we have an odd degree polynomial, our tails are going to go in opposite directions. So for f of x here that we have, 4 is an even number. Okay. Even means we're going in the same direction. On g of x, our degree is 3. 3 is an odd number. Odd means we're going in opposite directions. So the two O's stick together. Odd means opposite. Even means same direction. Here are some, I'm going to make it smaller. Is that all of them? Okay. Here are some other examples. Go ahead and pause the video and then write down, maybe I can slide him up a little bit and slide this one down. Okay, and determine at your desk or your bed or your kitchen table or wherever you're sitting what the ends are going to do. Okay, go ahead and pause the video, take some time to do that, and then turn it back on and we'll see what happens. So I've gone through and written down even degree means the same direction, odd degree means opposite directions. Once you've got them all done, double check your work and make sure you're on the right track there. When we said the leading coefficient is also useful to us. For the leading coefficient, we are worried about whether that coefficient is a positive number or a negative number. Okay, a positive number or a negative number. So back here on our 6 graphs, notice are on the top row, all 3 of them were a positive 1. Okay, the positive leading coefficient, okay, or any leading coefficient, is going to tell us what happens to the right end of the graph. Okay, so the leading coefficient on the top graphs were all positive 1. Positive 1 means my graph goes up as I go to the right. Notice that when I had a negative 1 for a leading coefficient, that means my graph goes down as I go to the right. Our leading coefficient always tells us what happens as we move to the right. Okay, and a positive number means up, and a negative number means down. Okay, so on our f of x, 2 is our leading coefficient. 2 is positive. That means it goes up as I move to the right. Okay, on g of x, the leading coefficient is negative 10. Negative 10 is a negative number, which means it goes down to the right. As we slide through, for h of x, negative 3 out in front means it goes down as we move to the right. And on k, positive 1 means I go up as I move to the right on my graph. Okay, go ahead and pause your video here and go through the rest from Q on down. Make sure that you know what happens as we move to the right on the graph. And then when you've got those all written down, unpause the video and I'll scroll through so you can check your work. So I already forgot where we left off, but as I scroll through, K I believe we did. On Q of x, we're going to go up to the right. R of x will go down to the right. P of x will go up to the right. And T of x will go down to the right. So what we'll be asked to do in one part of 3.4 is just to determine the end behavior. And it'll be with a little sketch with some little squiggly lines. Okay, we'll get into the specifics of what those graphs look like in another video. I want to keep these as short as I can. So f of x, we said the 4 was an even number, the degree was even, so both ends go in the same direction. We said the 2 is positive, which means it goes up as we move to the right. So if I go up to the right and I know both ends go in the same direction, then that means my end behavior looks like this. Okay, now I'm putting those dots there because I don't know if it goes like this, or maybe it just comes down real easily and goes back up with no humps or bumps. I don't know what happens in the middle, but I know on the ends, both ends go up. I know with g of x that the degree tells me my ends go in the opposite direction. I know the -10 told me I went down to the right. So if I'm going down to the right and in opposite directions, that means I'm going up to the left. Okay, so my end behavior graph or sketch or whatever the word the book uses, we're going to show an arrow that goes up to the left and down to the right, and some space in between because again I don't know what happens from there. So on h of x it says I'm going down to the right, and the even degree means I'm going in the same direction, which means I have to also be going down to the left. Go ahead and pause the video, finish your sketches for the rest of the graphs from K on down, and then turn it back on and see if you have the sketches right. So K was up to the right, opposite directions, which means down to the left. Q, both ends go the same direction, and so they both go up. Opposite directions in R, and down to the right means up to the left. Opposite directions in P, up to the right means down to the left. And T, they're both the same, and they both go down. Okay. We'll talk about using the zeros to sketch graphs in the next video. Practice some of these if you need to before we go on.